Hello. So welcome to our live Q&A. I'd just like to introduce myself. I'm Ahmad. I'm software engineering manager here at Meta. I have been here for around 7 years. I worked on ads, I worked on core systems, and currently working on data infrastructure. First of all, I would like to thank all our presenters here for the time and effort they put. I really enjoyed the talks today. I hope you also enjoyed them. And really, I would like to thank all the people behind the scenes here as well. From the people inside the company, outside the company, who helped like with the media production, with the blog posts, all the teams which have been behind the scenes putting and pulling this together on like a relatively tight deadline and timeline here, given that this is our first instance of systems at scale in EMEA. I'm really thankful for all the effort here. And I hope that you enjoyed the event as much as I am. I'm already looking forward to the next edition of this one. Cool. So thank you all, and let's get started with our live Q&A. And just as a reminder as well, you can send your questions in the live stream, and as they come in, I will be sharing them with our speakers as I'm moderating the session today. Cool. So with that, let's get started with the first question is for the Slick team. About SLOs adoption. So Philip, how can teams alert on their SLIs or SLOs? What's like your guidance on that perspective?
Thank you. So standard alerts can be configured in a Slick config. For example, users can config a burn rate detection, which can tell alert users on based on the current performance of their SLIs if they will violate their SLO in the future. People can also link custom alerts to their SLIs so they can see them in relevant contexts. And we also want to provide more insights here, as I mentioned at the end of the talk, to take this into consideration of how users should improve their SLIs.
Thank you, Philip. Cool. The next question is for the NVIDIA, so like that, Jared. Jared, how does Megatron compare with DeepSpeed from Microsoft and other pipeline frameworks?
So when we're building Megatron, we're really focusing solely on high-speed transformers and language modeling, and so we really built a custom solution that was custom for transformers and for running on supercomputers as opposed to running on, say, a cloud architecture or something. We kind of customized it to the supercomputer running on and the application, whereas DeepSpeed and some of the other stuff that Google has put out is a more generic solution that you can just throw any model at and it works. And because of that, they had to make some trade-offs and aren't able to kind of achieve the efficiency and the speed that we're able to do by customizing our solution for what we need.
Thank you. Cool. The next question is like for the remediations team. So that's Antonio. How do you balance fast processing of the alarms remediations versus the safety to not take down too much capacity at the same time?
Yeah, thank you. So basically, we will have in place some mechanism like the direct limit service that I briefly touched in the presentation. And they are there exactly to prevent this kind of problems. And they're people can customize them in exposing some of the metrics that they prefer to have for rate limits. But at the same time, we do provide some global rate limits to make sure that we don't have a massive spike of, for example, machines that goes to repair altogether. So those mechanisms are in place for the customer, but also for ourselves to avoid to get, for example, too many remediation at the same time. So we also are dog fooding the same solution.
Yep. Thank you. Cool. Our next question is like for Slick again. So David, this time, what's like your thought process about like out of the box SLIs or SLOs for services? So can Slick auto-generate SLIs and SLOs for teams?
Yeah, I think that's a really good question. We are working with some orgs in the company to try this out. And we are currently auto-generating availability and latency SLOs for these orgs. I also recommend listening to Behrouzi's presentation called Blaming in a Blameless World. This is from the Systems at Scale Fall Conference in 2021. And here we talked about auto-generating SLOs at Lyft. So that's quite relevant to this question as well.
Okay, that's quite nice. Thank you for the pointer as well. Okay, next question is for remediations, Leandro. What happens with failures whose actions to remediate them back to a working state are unknown?
Yeah, so that's a great question. So usually this will be troubleshooted by our data center technicians. They will investigate, like look for additional logs for any insights that can indicate like what problem we're having and how we might be able to solve it. Once they have a good idea, they would often like indicate what action needs to be taken. Either it could be like a manual repair action, like a swap, or it could be one performed by the automation to either like re-image the host or reboot. We'll carry those through. And the aim is that once we know now that for that particular failure signature, we can solve the way, we would either like embed that as a hard-coded rule so that next time we can take that automatically, or we would see if the machine learning model can automatically pick it up, that signal, so it can recommend that action next time the same failure comes into the pipeline.
I see. Yeah. Thank you. Next question is for Jared. So what are some of the issues that you faced when training the 530B parameter language model?
Yeah, thanks. There were two kind of things I didn't mention in the talk that we had to face. One was the data that we were training on, and the other was the precision that we were training in. So for the data, smaller models could handle a little bit not as clean data and some other things in the data. But as we got bigger models, they started to memorize the kind of bad data. And so we had to really make sure that the data we were putting into the model was all clean and was, we spent a lot of time kind of curating the data, making sure we had a good data set, as well as the precision. So for smaller models, we were able to just use a standard recipe where we're training with FP16 precision mostly, which is much faster than FP32 on our GPUs. But for the large models, the FP16 format didn't have enough range. And so we had to kind of go to different recipes, and we ended up doing the training in bfloat 16, which is a different numeric standard using 16 bits. And using bfloat 16, we're able to get the range. We had to figure out a slightly different recipe to be able to use that. So both the data and the precision were some of the things that we had to really focus on to get it to work.
Nice. Lots of challenges. Okay, back to remediations. Antonio, how do you manage the rollout of the machine learning model used in the hardware remediations pipeline? Antonio, I think you're muted. Yeah, thank you.
Sorry.
Yeah.
So I was saying this has been one of the challenges that we face, because potentially we do have mechanisms that they can roll out new model in production as we speak. So we have decided together with the data center technician to have a bit of supervised promotion sort of platform, so they can check by measuring the accuracy of the models with the past action that we've taken to see if it does make sense to proceed with the new model. So for now, it's a sort of partial manual operation, but we're working on making this like automatic.
Yeah. Cool. Philip, you mentioned that like you are a production engineer. So we're curious, like how's the work in the Slick team divided between software engineers and production engineers? And like what's like your view on this split in the team?
Yeah, I think that's a good question. So in the Slick team, there's no actually distinction between production and software engineers. We share the same on-call responsibilities, and we are basically all involved in projects that have to do with reliability, because essentially we are an infra team. So what's familiar to us is that we care about reliability fundamentally.
Thank you. Jared, a bit looking into the future, what are like some of the improvements to Megatron that you are currently working on?
Yeah, so one of I mentioned that we were working on different ways to do generation and control the generation, but more on the systems side, we're trying to make Megatron more memory efficient. Right now, when we aren't able to fit as much of the model on a device as we can, we do what's called activation checkpointing, which are, and as we go through the model, we're throwing away some compute instead of saving it. And then when we do the backward pass, where we're calculating the gradients, we just recompute a lot of the what's called activations in the model. But this ends up throwing away a lot of compute. So we're working on ways to be more memory efficient so that we can save those activations, save the compute instead of redoing it, and that way become more efficient in our usage of the model. So I think memory efficiency, as well as exploring different ways to improve the communication between both tensor and pipeline parallel, are different things that we're looking at on the system side.
Thank you. Another question for remediation, Antonio or Leonardo, like anyone can pick this up. Can you state the accuracy in percentages of the detectors, filters in discriminating between software-induced failure and the hardware-induced failure? For example, how many software-induced failures reported are actually hardware, and how many hardware-induced failures are software?
Yeah, I can take a stab at that. So I don't have a precise percentage right now, but that's one of our biggest challenges, like in this space, is because there isn't really like a clear cut where hardware failures begin and where software failures begin. Like it really depends. We have a lot of challenges where some silent errors, for example, can manifest like in weird ways, and we will notice that through the application. And also we have some application failures that may seem like a hardware one. So I'd say it's hard to give a number, like really, but I'd say it's really like one of the biggest challenges. Like we can have a machine unreachable, like for many reasons. That's kind of one of our biggest pain points. So what we try to do is to gather the most amount of signals from that device as possible, so we can correlate and infer like the best decision we can make at that point, looking for previous errors prior to that crash. And then we try to determine if they are more related to software or hardware. But it's tough to give it a number like right now on the spot.
Yeah, I understand. Thank you. Next question is for David, honestly. Going a little bit more technical here, why was the sharded MySQL database chosen as the storage layer? Did you evaluate any other possibilities? Why did you make the decision like that?
Yeah, I think that's a very interesting question. So originally in Slick, we were actually using a Hive storage solution. That's kind of a data warehouse solution. And eventually we moved to MySQL, and this managed to improve the query latency quite a bit. But we are still using Hive for some analytics use cases. So what we found at the end is that the combination of MySQL and Hive works the both, even with the added storage cost and the added complexity, because they are kind of useful for different use cases.
Thank you. Antonio, can customers specify multiple steps in their remediations? If you are familiar with AWS Lambda step functions, can people do the same in our system? I think you're on mute.
I really don't know how to unmute myself.
Yeah.
So, yeah, so a customer can. So they can specify a flow in the remediation. They split it in stages. They're very equivalent to the one that we have in AWS Lambda. They're called step function. So they can say, do this step and then move on into some other logic. This is good also for them to break the logic in isolated parts. And it's also good for us because we know how to better schedule those like smaller chunks of components that we want to run.
Thank you. Okay, Leonardo, that's like an interesting question that I would like to know the answer for as well. How much data do you use to train the model behind repair and training?
Yeah, so that's another one which we are constantly like experimenting with, like as of latest, like we have been using like the past 6 months of repair data. So we basically like look back 6 months of this historical data all the failures that we have processed and what were the actions that resolve those conditions in order to train the model. But we try to balance, because if we train it with a very old data set, it may happen that the errors that we see now are no longer present, so that model is less relevant. But also we can't be running a model like in the bleeding edge, like of the repairs, because we don't know yet if the actions taken are actually the ones that are resolving the problems. So that whenever we have in this data set, we exclude like repeated offenders, so that we try to trim it down to the actual repairs that actually resolve the bad condition, and not just like paper it over, like because we reboot the machine and we clear the logs. So we are in current like experimentation, but so far we have found most success with like a 6-month like rolling window for the data set.
I see. And so if you don't mind, like a follow-up question on that, what happens if the model suggests an action with low confidence?
Yeah, so we build in the platform like in Repair Brain. We have like a blocker list. So we have all the specified thresholds that were analyzed by all the peers like involved in the space. If it doesn't reach that threshold, the platform will simply just mark it as blocker list. So we will know, like we have all the alarming and monitoring around it, but that action will not be carried through. For the ones that are above the certain threshold, then the platform will proceed and take that action, like either automatically, or it will create a ticket if that requires like a human intervention to be performed.
I see. Yeah. Thank you. Okay. Our probably last question, Filip from Slick. How often are the Slick data pipelines run? Like, is Slick like a real-time system, or how does this work?
Yeah, so that's interesting. We didn't mention specifically in the presentation, but we run pipelines on hourly and daily basis. So essentially, it's a batch system. But for visualizing the SLI data, we render a combination of real-time and long-term data. So we can leverage the 2 weeks of full granularity we have from the standard real-time monitoring infra at Meta to present it to our users. And also another interesting thing is that for detection, we also rely on the real-time data from standard infra, as usually for detection, we will have a much shorter, I would say, detection windows.
Okay. Thank you, everyone. I think that's it for our Q&A today. I don't see more questions coming. So yeah, again, I want to thank you all for the time and effort that you put behind the presentations. And a big thanks for all the people behind the scenes, the people on the program management, the people who just made this happen in systems at scale in EMEA. And I'm really looking forward to the next editions of this. Have a great day and enjoy the holidays, everyone. And it was really nice to host you today. So thank you. Bye.
Thank you.
Thank you, everyone.